Limiting reagent problems. In our stoichiometry problems, 4-step problems, up to this point, we have been given one substance and asked about other substances. Although we haven't stated this directly, we have assumed that there was more than enough of each of the other reactants to react with what we were given. We have not paid any attention to the possibility that something else will run out before what we were given. But what if things are more like real life? What if we know how much of each of the reactants we have? Then how do we proceed? Let's look at a different situation from real life for a moment to get us started. Suppose, just for the sake of argument, that I am a maker of tricycles. In order to make a tricycle, I need one frame, 3 wheels, let's assume they're complete with spokes, tires, and tubes, 1 seat, 2 pedals, and 1 set of handlebars. Let's also suppose that I have in my inventory 120 frames, 390 wheels, 85 seats, 500 pedals, and 100 sets of handlebars. How many tricycles could I make? Well, if I look at the frames, I could make 120. Looking at the wheels, 130. 85 from the seats, 250 from the pedals, and 100 from the sets of handlebars. So how many complete tricycles could I actually make? Of course, the answer is 85, because after I made 85 tricycles, I would have no more seats and could not make a complete tricycle. So the number of seats limits the number of tricycles I can make. Seats are my limiting component for making tricycles. This is true in 2 ways. First, they get used up first. And second, they produce the fewest tricycles. This second way of looking at it will be important for us later on. I will have extras of all the other components of the tricycle. Let's go back to chemistry and look at the following problem. When zinc metal is added to nitric acid, HNO3, the skeleton reaction shown below occurs. If 48.6 grams of zinc are added to 120.3 grams of nitric acid, what mass of water is produced? The first question is, what kind of problem is it? We have a chemical reaction, and we are trying to relate the substances in the chemical reaction to each other. So it is a 4-step problem. What is different about this problem from a normal 4-step problem? The answer is that I have 2 givens rather than just 1. These are the 2 things that make a problem a limiting reagent problem. 1, we have a 4-step problem, and 2, we have 2 or more givens. Let's define some terms here. Limiting reagent, the reactant that gets used up first. It is also the reactant that produces the smallest amount of product. Excess reagent, any reactant that is left over. You may pause the video here to write these down if you wish. How do we proceed? Since this is a 4-step problem, let's follow the steps for a 4-step problem. The first step is write and balance the equation for the reaction. The skeleton reaction is given, and since this is a difficult reaction to balance, I will also give you the coefficients. We have 2 givens. Which one gets used up first? There's a lower mass of zinc than of HNO3, So is zinc the limiting reagent? Remember that zinc and HNO3 will almost certainly have different masses, so we shouldn't necessarily judge by the number of grams. So let's move on to the second step. The second step is to find the moles of the given. We have two givens, however, so let's find the moles of both and see where it leads. For zinc, we divide the mass of zinc by the molar mass of zinc. 48.6 grams of zinc divided by 65.39 grams per mole gives 0.74323291 moles of zinc. For the HNO3, we do the same thing after determining the molar mass of HNO3. 120.3 grams of HNO3 divided by 63.012 grams per mole gives 1.9091616 moles of HNO3. Is it clear yet which of the two givens will be used up first? You might think that, since we have fewer moles of zinc, that zinc would be used up first. But if you look at the balanced equation, you see that you need much more HNO3 than zinc. So let's wait to make that decision. The third step is to use the mole ratio to find the moles of the unknown. We take the moles of the given and multiply it by the mole ratio. For zinc, we have 0.74323291 moles of zinc. The unknown is water, so the mole ratio is 4H2O over 3 zinc. This gives us 0.990977214 moles of water. For HNO3, we have 1.9091616 moles of HNO3 times the mole ratio, 4H2O over 8HNO3, which gives us 0.9545808 moles of water. Since the HNO3 produces less water than does the zinc, the HNO3 is the limiting reagent. Let's go back and look at the three places where we might be tempted to make a decision about which given is the limiting reagent. First, let's look at the mass. The mass of zinc was less than the mass of HNO3. The moles of zinc were less than the moles of HNO3. But the moles of water produced were less for the HNO3 than for the zinc. So HNO3 is the limiting reagent. Despite the fact that there was a lower mass of zinc and that there were fewer moles of zinc, it was not the limiting reagent. So we should not try to decide which reactant is the limiting reagent until we can compare the moles of unknown produced after doing step 3 for all the givens. Now that we have determined that HNO3 is the limiting reagent, we can ignore the zinc and continue with the problem. The answer. The answer is the number of grams of water. Grams of water equals moles of water times the molar mass of water. Grams equals 0.9545808 moles of H2O times 18.015 grams per mole, which equals 17.1967614. Since the molar mass of HNO3 is good to 4 sig figs, so is our answer, 17.20 grams of water. Note that, even though the number of sig figs in the mass of zinc is only 3, 48.6 grams of zinc, we use 4 sig figs because we did not use the mass of zinc to determine the amount of water we finally got. we use the mass of HNO3. Here are the 4 steps again, modified to deal with limiting reagent problems. Step 1. Write and balance the equation for the reaction. Step 2. Find the moles of each of the givens. Step 3a. Use mole ratios to find the moles of the same unknown using each of the givens. 3b. The given that produces the least amount of unknown is the limiting reagent. Ignore the other givens. Continue with the problem with the smallest amount of the unknown. Step 4. Find the answer. You may pause the video to write this list down if you wish.